So now we're going to talk about composite reflection over parallel lines. So a composite reflection, remember, is reflecting over not first one and then another line. When we looked at intersecting lines, we saw that when we reflected first over one and then another, we reflected that point, right? Then we ended up with a rotation. So if we look at this, we actually end up with a rotation that is twice the angle between the two lines. Something similar happens when we reflect over two parallel lines. So let me just show you. So if I have this shape and I reflect, let's say, first over this line and then this line, so we'll do a reflection and we're going to reflect first over this line, that object, then it gets reflected as we expect, right? So there's our A prime, B prime, C prime, etc., right? So now let's select the right tool here, because this would be B prime, this would be A prime, and then this would be C prime, okay? So now if we define another transformation, another reflection specifically, and we choose our line of reflection, right? And we apply it to this object, that is, now we're going to make this a double prime, we can see that, well, so we can tell the difference, that this will be B double prime, this will be A double prime, and C double prime. Now the key thing to focus on when we're looking at this is what is happening from the first to the last. So if I'm looking at B, it is going all the way over here to B double prime, C to C double prime. And now we know that when we do reflections, it actually ends up changing the orientation, right? ABC versus ACB. But when we reflect twice, the orientation changes back. So I would argue that what we're looking at here is a translation, right? In this direction, in this particular case, so to the left of, well, how far has it gone? 1, 2, 3, 4, 5, 6, 7, 8 units. So it's gone -8, 0 in this case, right? Now, what happens when we change some of the variables? Now remember, the rotations were twice the angle between the two lines. So let's take a look. If we increase this, it increases the translation. As a matter of fact, if I increase the distance 1 unit, it increases the translation. Well, watch. This is starting there, it's increasing 2 units. So if we look, we can see that the distance between these two is precisely 4 units. And then the translation ends up being 8 units. So, to sum up, result of a composite reflection over two intersecting, that's a typo, that should say parallel lines, is a translation, right? And the amount of the translation is twice the distance between the two parallel lines. So if they're 4 apart, it translates 8. If they're 5 apart, it would translate 10. The direction of the translation is the direction from the first line of reflection to the second line. So if we take a look at this and we reflect first over this line and then over this line, it moved it this way. Well, let's take a look. What if we reverse that? So what if we did our transformation and we got rid of this and we got rid of this and we translated first over this line, and then we defined another reflection and we translated second over this line. So now we're going to reflect this. Now unfortunately it looks like nothing's happened. So what actually has happened is I think these things are too far apart. So here's what I'm going to do. I'm going to go ahead and move this way, move this way, and I think you can see that we've reflected first here, then over here, and the distance between these is 1, 2, 3, 4, because the distance between the two lines is. Because remember, we reflected first over this line, and then over this line, and so the direction between those two lines from 1 to 2 is that way, so the translation is that way. Okay? So that about sums up what we need to know about translating over parallel lines. That is a composite translation, or sorry, composite reflection over parallel lines.